Hello YouTube, hope you're doing well. So in this episode we're going to look at a little bit of restructuring and testing of the code we've been writing in the two previous episodes. So the first thing we're going to do is to move some of our code into new files. So before we had everything in main, but now we're gonna put all the chess specific stuff in game.rs and utility functions that don't really refer to anything to do with the chess, we put them in utils.rs. Let's start by taking a look at the main rs. So now it's almost empty. We've moved, as I said, all the functional code into two new files. So we need to declare them in the main file so that the cargo system knows that these are modules that are part of this program. And the way you declare them in Rust is just you write a module game and module utils, and then we are importing everything from the game file, and we'll look at that later. But then the main function is unchanged, and if we run it, we get the same output as before. So let's now take a look at the utils file. So as I said, it has everything that's unrelated to chess, which is actually not a lot. It's only the efficient Bitscan implementation and the split on function. And as you may note that we have made them public now, so that when we in another file we say use utils ::* we get all the public functions, so we don't have to specifically import these functions. So let's add some tests, which I've done here. In Rust, you're kind of encouraged to add your unit tests inside the same source file as the functions themselves, which you could argue is a nice thing. Everything is together, and you kind of write the tests as you're writing the functions if you do it the right way. So to add some tests, you start by this configure test macro, and then you put a module called tests under that macro, and inside the tests module, you write all your test functions. So we only have two here. Now to use all the functions in the surrounding scope, you have this using statement here, use super and take everything. And it also only imports the public functions, I think. But in any case, you could always import specific functions if you needed them. So to write a test, you simply annotate them with a hashtag test, and then you have some test code. Now, if the function panics, then it will be considered a failed test, and if it doesn't panic, it will be considered a successful test. And there are all sorts of macros that you can look up to have some of this testing functionality. For example, here there's assert equal, where we can test two things whether they're equal. So the first function is just very simple, that we test that split on a space works. So we have a test string that is a space b space c space d. We call the split on function, and then we assert that the first part is just an a and the rest is just b, c, d. Now in the second test, it's a little bit more general. It's testing all ASCII characters from 0 to 127. And just to avoid handling a special case, I just skip the A character. But then we make a test string that is, now it's two A's, and then it's the character that we chose up here. Then it's the two B's, again the character, two C's, and so on. So I just use the format macro that inserts character into all of these braces. Then again we call split, And now the first part should be AA. And then there's here an error message. If it goes wrong, we can see what happens. And the rest should be the rest. It should be BB, the separator CC, the separator DD. So in particular, one of the things we're testing here is that we always skip the separator. So you can see that if you combine this string with that string, you will actually be missing the separator. And that's intended functionality. So now we have some pretty thorough tests for this. And now we can just run it by running the shell command cargo test. It will go into the source files, look for test modules, and then run it. So you can see here that it's found our 2 tests, it ran them, and they were both okay. We could cause a test to fail just for fun. So just for fun, let's see what happens. Now you can see it's reporting it as failed instead. And the error message is panicked at just for fun. Let's remove that again. Now let's also write a test for the Bitscan. So here we have a test for the Bitscan. I just test all possible input, all possible 1-bit input, so all strings that have exactly 1 bit set to 1, for example like this. And then I call the Bitscan, and it should find that this index that it returned should be the same as I. So we can also do a little bit of extra testing. So we can test that Bitscan works if highest bit is 1. So let's make it mutable, and then we say add a 1 bit at the highest location. So because Bitscan is finding the lowest, actually I think this should fail. So let's run it. So you can see it failed, and it failed because the method that this Bitscan is based on is assuming that there's only 1 bit set. And now the way we can fix that, or this is so another way to say that is that the fact that the test fails, if we try to run it again, the fact that it fails is actually expected behavior. This is what it should do. Perhaps it should even fail a little bit harder. Now it's only failing because the result is not equal to what we would expect. But anyway, it should fail. So one way you can make a test that should fail is by adding the annotation should panic. Now if we run the test command, all the tests are reported as okay again. So you could argue that we need to change this Bitscan function so that it automatically fails if there's more than 1 bit set, or you could argue that we have to change it so that it can actually works for multiple bits set. But for now, we'll just leave it as it is. Let's now go have a look at the game RS file. So it looks basically like the top of the main file, the old main file. The only one new thing is that we now use the utility functions. We import everything from the utility functions module. And when you want to import something from the package you are making now, your own package, you use this use crate. No matter what you call your package, we call our package Chesscomputer, but you still use the crate word. So you say use crate, and from the utils module, import all the public functions. And again, we make all the functions public, so that basically all the functions public, so they're easy to use from other places. And maybe we're not using all of these right now, but it will just turn out to be convenient later. In particular, we're also making all the fields of the game struct public, because we definitely want to access them from other places. Now we also refactored the game a little bit. So the initialize function now just calls the read FEN function, but with like the initial position FEN string. So we avoid having multiple large pieces of code that actually do the same thing. And of course, if we have some kind of bug, then we'll only have to fix it in one place. It's just the do not repeat yourself principle. And that's basically it for moving all the files in here. So let's have a look at testing the game. So the structure is the same as before. First we configure test, we call configure test, then we make a module called tests. Then we use all the functions from the surrounding module. And now the code that was in initialize before, we've actually moved it in here so that we can use it as kind of a reference to check that our FEN, read FEN function is doing the right thing. So I'll just skip that. That's exactly the same as was in initialize before. And then we will start having some tests. So the first one is to test that when we call the initialize method on game, or the initialize function on game, we actually get the correct position. So first we make a variable called game, that is the initialized game. Then we call this helper function that was initialized before to make the expected, the correct one. So then we have a bunch of asserts. So in the starting position, it's white to move. All the castling rights are conserved. There's no en passant. The half move clock is 0. The full move number is 1. So those are just the basic sanity checks that of course should hold. And now we want to check that each square has the correct piece on it. And the way we check for a correct piece is by comparing to the default variable. So first we loop from 0 to 64, checking all the squares. Then we do some pattern matching. So the reason is that the pieces in the game variable, so the pieces array may not have the same ordering as the pieces in game, may not have the same pieces ordering as the pieces array in the default. So we have to take a little bit of care, but we do some pattern matching on the squares. The squares have to have the same ordering. Now, so either they are both empty, so that's good, or they're both occupied with some index. So this index will be into the pieces array of the game variable, and this index will be into the pieces array of the default variable. So we cannot assume that the indices are the same, but at least the pieces should be the same. So that's what we do here. We assert piece at index 1 is the same as piece at index 2 in the other variable. And if so we now match them these two patterns, and if there's any other pattern, so for example empty occupied or occupied empty, then obviously there's something wrong. So we call panic. Then we have some other tests. We read a FEN string where we force it to be black's turn, and then we assert that the active color is black. Then we read an FEN string that has no castling rights. Castling rights should be none. Then we read one where en passant is allowed, and here we set the en passant square to G7. We put that in here in the FEN string using format, and then we assert that the en passant square on the past game struct is equal to this square if we turn it into a bit string. Then we have some on the move clock. It's not so interesting to go over. Then we have this function where we consider all possible castling rights. So the way it works is that we have this rights variable, which will eventually turn into either K or KQ or lowercase k, you know, all sorts of combinations that we can think of. So there are four letters in the castling rights, 4 possible letters, and each of them can either be there or not be there. So there's 2 to the 4 possibilities. That's where you get this loop. And now we just want to make a castling rights bit flag. That's very easy because we just convert the integer into like this, into a bit flag like this. And then we want to make the castling rights string. So then we loop over all the bits in I and we check, is that bit equal to 1? If it is, then we put in the corresponding character that we have here. And then we make the FEN string, we read it, we check that the passed castling rights is equal to the expected castling rights. And then we clear this rights variable for use in the next iteration. So let's run that. And now you see it failed because it wants to copy a square, so it doesn't. You know, or rather, it's trying to do a move of the square because the square is not copyable, and that will cause some issues with the borrow rules because we cannot move the square out of this vector which owns it. So, easy way to fix that is to go to the square and say, okay, actually, we want it to be copyable. Now then we actually need clone as well to make copy work. Now we've run it. So we see that there are actually 2 tests that fail, and they're both related to castling rights. And here we can see the failure messages. So it panicked. So in the all possible castling rights, it panicked here where it said that, okay, it expected. Let's go down there again. So it got the castling rights. The actual value was all, but it actually expected none. Let's have a look at the other test. This one. There should be no castling rights, but again it had got all, even though it expected none. Now the reason for that is actually if we go into the read FEN function, not that one. And we go to the castling rights. Here, if you recall, we construct the castling rights and put it into this castling variable, but we never actually set it on the game. So this was our bug. And now the test should be passing. And that's it.